Today we're going to do questions 13 through 24 of the January 2016 Algebra 1 Regents. So question 13 says, the table below shows the cost of mailing a postcard in different years. During which time interval did the cost increase at the greatest average? Okay, so they give us 4 time intervals, meaning that for each interval, we need to test what the rate of change was. So the first interval we're going to look at is 1898 to 1971. So to do that, we have to do y2 minus y1 divided by x2 minus x1. So we're basically just going to subtract the years, subtract the cost, and divide. In this case, the year is x and the cost is y. So I'm going to do the cost first since y is in the numerator. So I'm going to do 6 minus 1 divided by 1971 minus 1898. 6 minus 1 is 5 divided by 1971 minus 1898. Let's do that in the calculator. 1971 minus 1898. It's a difference of 73 years. And 5 divided by 73 is 0.0. I'm going to put 7 because since this is money, we're going to have to round it off. But for now, just because we actually don't know the price of the rest of them, I'm not going to round it just yet. I'm going to wait. So 0.068493, that should be more than enough. Okay, our second rate is going to be from 1971 to 1985. So I'm going to start with the y first. So this time it's 14 minus 6 divided by the year, which is 1985 minus 1971. So 1985 minus 1971, that's 14 years. We're going to have 14 in the denominator. And 14 minus 6 is 8. And 8 divided by 14 is 0.571428. Okay, so already it wants to know which is the greatest. So it's already not 1, because 2 is larger. Okay, now let's do the interval in 3. Now we have 1985 and 2006. So this time it is 24 minus 14 divided by 2006 minus 1985. Well, 24 minus 14 is 10. And 2006 minus 1985 is a difference of 21 years. And 10 divided by 21 equals 0.47619. So again, 2 is still larger, so it can't be 3. And now we just have to test our last interval. This one is from 2006 to 2012. So we're going to do 35 minus 24 divided by 2012 minus 2006. 35 minus 24 is 11. And 2012 minus 2006 is a difference of 6 years. And 11 divided by 6 is 1.833 with 3 repeating. And now that's the only decimal that went above 1. So it's not 2 anymore. Our answer here is 4. Question 14, when solving the equation x squared minus 8x minus 7 equals 0 by completing the square, which equation is a step in the process? Okay, so to complete this by square, so x squared minus 8x minus 7 equals 0. The first thing we want to do is move the constant over. So we're going to add 7 on both sides. We get x squared minus 8x. We're going to leave a blank space here for the moment. Equals 7. And we're leaving a blank space there because we need to take our b, right? So this number here that's in front of x, we're going to take half of it. So negative 8 divided by 2 is negative 4. And then we're going to square that number. Negative 4 squared equals 16. And we're going to add 16 on both sides now. Okay, we do that because now we can rewrite the left side as x minus 4 squared. And that's coming from here. So x minus 4 squared equals 7 plus 16, which is 23. And while there is more to the process, this is where we can stop because it didn't ask us to actually solve it by completing the square. It said what is a correct step. So as we can see, we know 2 is the correct step now because that's exactly what I got here. X minus 4 squared equals 23. Question 15, a construction company uses the function f of p, where p is the number of people working on a project. To model the amount of money it spends to complete a project, a reasonable domain for this function would be positive integers, positive real integers, positive and negative integers, or positive and negative real numbers. Okay, well, P is the number of people working on a project. Remember, domain means input. In this case, P is the input, and P is the number of people. So we cannot have a negative number of people, so it cannot be 3 or 4. And the difference between integers and real numbers is that integers are whole numbers, while real numbers can be decimals. And we cannot have half a person or 2.7 of a person. So it can't be the real numbers, it has to be integers. Okay, question 16, which function is shown in the table below? So whenever you're looking at a table and thinking about functions, the first thing you want to do is look for the rate of change. So in this case, from 1/9 to 1/3, it looks like we are multiplying by 3. Or we could say adding, but adding would get a little more tricky because that would be 1/9. Basically, 1/9 plus what would give you 1/3 which is 3 over 9. So we could say we're adding 2/9, but simpler than that is to multiply by 3. And if you look at the next difference, 1/3 to 1, that's multiplying by 3 again. 1 to 3, you're multiplying by 3 again. 3 to 9 by 3. 2 to 9 by 3. And our options here are 3x, x plus 3, negative x cubed, and 3 to the x. So we have 3 different types of functions here. We have, these are linear. Three is cubic. We know that because of the 3. And 4 is exponential. And we know it's not linear because if it was linear, it would have a constant rate when we're adding. Here we do not have a constant rate when we are adding. Instead, we have a constant multiplied rate. And that's this times 3. So times 3 times 3 times 3. So this is actually going to be exponential. But if you forget those rules, the other thing you can do is go into y equals and plug each option in. So like 3x, you would then go to second graph. And you can see that at x is -2, this is saying y is -6, not 1 over 9. But if we were to put 3 to the x, okay, you see we get a long decimal here, long decimal there, but let's look at the other numbers. We got 1, 3, 9, 27. And you see 0.11111 and 0.33333. If you test those fractions, 1 divided by 9, you get 0.11111, and 1 divided by 3, you get 0.333333. So you could have also used the graphing calculator for this. Okay, question 17. Given the functions h of x equals 1/2 x plus 3 and and j of x equals the absolute value of x, which value of x makes h of x equal to j of x? Okay, so we have 1/2 x plus 3. The question wants to know what makes them equal. So we set them equal to each other. Okay, and when we have the absolute value of x, basically this can be split into x and negative x. Because the absolute value of x is x, and the absolute value of negative x is also x. I'm going to just get rid of the absolute value bars and then write this again. 1/2 x plus 3 equals negative x. And now you just solve each for x. So I'm going to subtract 1/2 x. And 1 minus 1/2 leaves you with 1/2. And this is, remember, a fraction means division. So if we multiply both sides times 2, this is 6 equals x. So 6 is an answer choice, but we don't actually see it in our answer choices. So let's solve the other one now as well. So I'm going to subtract 1/2 this time, just like before. But now we have -1 minus 1/2. So we're going to get negative 3 over 2x. Okay, and we're going to multiply both sides by 2 again, because that's what we're dividing by. So this 2 is gone. We get 6 equals negative 3x. Divide both sides by negative 3, and you get negative 2 equals x. So our answer is going to be 1, negative 2. But this is also another graphing calculator question. So let's take 1/2 x plus 3 and y1 and the absolute value. So now I'm going to press math. I'm going to go right to num, and we got abs here, so absolute value of x. We're going to go to second graph, and now we're looking for the numbers where y1 and y2 are equal. So we see that happens at negative 2 because y1 and y2 are both 2. And according to the work that was done before, it should also happen at 6. So it's 6, y1 and y2 are also 6. Okay, question 18. Which recursively defined function represents the sequence 3, 7, 15, 31? Okay, and what's going to be helpful? Well, first here we see that we're starting at 3. So that's going to be important to notice, except that each option tells us to start at 3. So unfortunately, that won't be too helpful. So we look at the second number. So we go to 7, which is adding 4. So now let's see if we can use these rules in each option to get 7 as our next number. So let's start with this one. So this says that f of n plus 1 equals 2 to the power of f of n plus 3. Okay, and we already know f of 1, right? So we know, put this off to the side. We know f of 1 equals 3. Well, if we wanted to find f of 2, that would be f of 1 plus 1. So in this case, n is 1. And that equals 2 to the f of 1 plus 3. And we know that f of 1 is 3. So this becomes 2 to the third plus 3. 2 to the third is 8, plus 3 is 11. And 11 is not our second number, 7 is. So it's not number 1. Okay, let's try option 2. This time we have f of n plus 1 equals 2 to the f of n minus 1. Well, just like in the problem before, we found out that 2 to the f of 1 is 2 to the third, which is 8. So I'm just going to write that in now. We got 8 minus 1, which equals 7. So that's looking good so far. We have to test the next one, though. So now we need to find f of 3. And f of 3 is going to be f of 2 plus 1, making this time n2. And that equals 2 to the f of 2 minus 1. And in the last problem, we found out f of 2 is 7. So that's going to be 2 to the 7th minus 1. And 2 to the 7 is 128 minus 1 is 127, which is not 15, so it's not option 2. Okay, so I'm going to have to erase all this to make some space. I press that. Hopefully that goes a little quicker. No. Okay. So now we can go back. Now we're going to do option 3. This time we have f of n plus 1, which equals 2 times this time. So 2 times f of n plus 1. And again, we know that f of 1 is 3. So to find f of 2, we would have to do f of 1 plus 1, which would be 2f of 1 plus 1. So 2 times f of 1, well, f of 1 is 3, plus 1 is 7. So far, so good. Remember, this is f of 2. So now to find f of 3, we would have to do f of 2 plus 1, which is 2 times f of 2 plus, 2 times f of 2 plus 1. So we have 2 times f of 2, and we know, because of the last problem, that f of 2 is 7. So we're going to substitute that in right now. Plus 1, 2 times 7 is 14, plus 1 is 15. All right, let's do the last one. So we got we got to do 3 plus 1 this time. 2 times f of 3 plus 1. And now we know that f of 3 is 15. So we're going to get 2 times 15 plus 1, which gives us 30 plus 1, which gives us 31, which is also the 4th number now. So our answer choice here is going to be 3. Using that rule, 2 times f of n plus 1 gives us every number in the sequence. Okay, question 19. The range of the function defined as y equals f to the x power is, well, let's look at this graph. 5 to the x. So looking at that, the graph here, we can see that this graph never goes below the x-axis. Never. So because of that, our range, which is all the y values, it can't go to the negative y values, which means that it always has to be greater than 0 But even though it looks like it touches this x-axis, it's never going to actually touch it either. So this one is just y is greater than 0. And that's going to be true for any exponential function that looks like this. So when you have a positive number, so I'll say p to the x, this is always going to have a range that is greater than 0 because it's not going to touch the x-axis. All right, question 20. The graph of f of x is shown below. What is the graph of f of x plus 1 minus 2? Okay, so for here we need to know transformations. When we are adding and subtracting inside the parentheses. So let's start with inside the parentheses. This is going to be a left and right shift. When we're adding, we shift left, which I guess I should change my arrow direction. And when we subtract, we shift right, which seems a little backwards, but just try to remember when you're inside the parentheses, you're backwards. So this plus 1 actually tells us to shift 1 left. So that's definitely the first thing we should look for, that we're shifting left. The other thing we need to look for is this minus 2. So outside the parentheses is going to be an up and down shift. When we add, we shift up. And when we subtract, we shift down. So outside is not backwards. That's normal, if you want to say. So now we just need to look at every single graph and see which graph was shifted once to the left and 2 down. Well, you can start point by point here. I'm going to start with this point I just graphed in red. So that started as the point 2, 3. But if we move once to the left and 2 down, we should have a point at 1, 1. So we have a point at 1, 1 here. In option 2, there is no point at 1, 1. At option 3, there is no point at 1, 1. In option 4, there is no point at 1, 1. So 1 is our answer. Okay, question 21. Which pair of equations could not be used to solve the following equations for x and y? Okay, so they want to know which one is incorrect. So for these, what you need to do is figure out if you're solving these by substitution. It's a system of equations. So are we solving by substitution or elimination? Whenever you see substitution, there will likely be parentheses. And since there are no parentheses, we can say that we're substituting by elimination. That was weird. So now that we know that we're solving by elimination and not substitution, we're going to take our original and we're going to try to solve it for each example. So we start with 4x plus 2y equals 22, and 2x minus 2y equals, I was looking at the wrong thing, negative 2x plus 2y equals negative 8. So in question 1, we can see that the top equation hasn't changed. 4x plus 2y equals 22, but the bottom one has. And what's changed about it is the signs. So in order to change all the signs, all we would need to do is multiply the bottom by -1. And that would give us positive 2x, negative 2y, and positive 8. So that looks doable and correct. So 1 is good. I'm just going to erase these markings to not have to rewrite it a bunch of times. Okay, now let's try option 2. So again, we can see 4x plus 2y equals 22. That didn't change here. But what did change, not the signs this time, but the numbers in front. So what would we have to multiply this by to get 4 instead? It would have to be 2, right? So 2 times -2 gives us -4x. 2 times positive 2 would give us positive 4y. And 2 times -8 will give us -16, which is exactly what we got here. So 2 is also a good example, a good option. All right, we're going to move on to 3 now. So in this one, actually both of our equations are different. So for the top one, we had 4, 2, and 22. Now we have 12, 6, and 66. And for the bottom, we had -2, 2, and -8. Now we have 6, -6, and positive 24. So let's start with the top. So we have a 4, but it became 12. So what do we have to multiply 4 by to get 12? We have to multiply it by 3. And now you actually want to multiply out to make sure that this is correct. So 4 times 3, or 3 times 4 is 12x. 3 times 2 is 6y. And 3 times 22 is 66. So that one looks good so far. Let's do the second one. So we have -2, but they want positive 6. So we must multiply by -3. -3 times -2 is positive 6x. -3 times positive 2 is -6y. And -3 times -8 is positive 24, which is exactly what we got there as well. So 3 looks good. So since 1, 2, and 3 are good, that's going to mean that 4 is our answer. However, let's just check and make sure. Okay, so our top equation here changed. So we started with 4 and we went to 8, right? So what do we have to multiply 4 by to get to 8? We have to do 2 times 4. Now let's check the rest of them. 2 times 4, we get 8x. 2 times positive 2, we get 4y. And 2 times 22, we get 44. Right, that one looks good so far. Now let's check the bottom. We started with the -2. We ended up with the -8. 4 times -2 is -8. So we get -8x. 4 times 2 is positive 8y. And 4 times -8, well, 8 and 8 is 16, and 16 and 16 is 32. So we get -32. As we can see, that is where our error is. So our choice is 4 because it cannot be used to solve. Question 22. The graph representing a function is shown below. Which function has a minimum that is less than the one shown in the graph? Well, first, the minimum of this graph is at this vertex here. And that is the point 1, 2, 3. 1, 2, 3, 4, 5, 6. I feel like I counted that wrong. 1, 2, 3, 4, 5, 6, 7. Right, so that is the point 3, 7. So we say that the minimum is 7. So which function has a minimum that is less, the negative 7? The negative 7, right? So let's use our graphing calculator for this one. So we go to y. We're going to do x squared minus 6x plus 7. Second graph. So we see that we have a pattern of 7, 2, negative 1, negative 2, negative 1, 2, and 7. So our smallest number here is negative 2, which means this is our minimum, and it is not smaller than negative 7. Okay, y equals. Now we have the absolute value. So math, num, abs. I'm going to put x plus 3. Close out the parentheses, and some calculators you'll actually see the absolute value bars. Make sure you press the right arrow to exit the absolute value bars. Minus 6. Second graph. We're looking for that same pattern. So we see that right now we're going up, right? We're getting bigger, negative 2, negative 1, 0, 1, 2, 3. So I'm going to scroll up until I start to see. So now I see that it started to go back up, right? So it went negative 3, negative 4, negative 5, negative 6, and then it went back to negative 5. So that means our minimum in 2 is negative 6, which is still not less than negative 7, so it's not 2. Back to y equals x squared minus 2x minus 10. Second graph. We can see that that turning point happens down here because we have negative 10, negative 11, and then back up to negative 10. So our minimum for this one is negative 11, which is less than negative 7, so our answer is 3. Question 23. Chrishem is considering the 3 situations below. For the first 28 days, a sunflower grows at a rate of 3.5 centimeters per day. The value of a car depreciates at a rate of 15% per year after it is purchased. The amount of bacteria in a culture triples every 2 days during an experiment. Which of the statements describes a situation with an equal difference over an equal interval? Okay, so they're saying this a little complicated. However, equal difference is talking about the change in y, right? So how much is this, if we have a graph, how much is this changing in the y direction? And over an equal interval, it's talking about the change in x or the x-axis. And if you recall, comparing the change in y to the change in x is really just another way of saying rate of change. And because they use the words equal, they're looking for a constant rate of change. So this is really just a really fancy, complicated way of saying they're looking for a linear function. And the only linear function here is 1, so our answer choice is 1. We know that 2 is not linear because it's changing at 15% each year. Once you see a percent, that is not linear. And we know 3 is not linear because it's tripling. We're multiplying by 3. We are not adding or subtracting at a constant rate every day. So our answer is 1. And last question of this regent, question 24. After performing analyses on a set of data, Jackie examined the scatter plot of the residual values for each analysis. Which scatter plot indicates the best linear fit for the data? Okay, so we are looking for the graph that when you kind of draw a line or you draw a graph through these points, even if it's not hitting every single point, it's just like your best fit. So in 1, we can see that our best fit is actually looks kind of quadratic here. It's curved, definitely not linear. In 2, kind of looks like an absolute value. Again, definitely not linear. In 4, we can see that looks like an upside down parabola. But in 3, if we were to draw a line of best fit, it would pretty much just be the x-axis. So our answer is 3 because that's the only one that looks like a line. Okay, this was the January 2016 Algebra 1 Regents, questions 13 through 24.